S bar R bar latch. For this circuit we will use NAND gates, two NAND gates, 1 and 2. Input to first NAND gate is S bar and output of first NAND gate goes to the input of second NAND gate. Output of first NAND gate is QT, which is present state, and output of second NAND gate goes to the input of first NAND gate. Output of second NAND gate is QT bar, which is complement of QT. And second input to second NAND gate is R bar. Now we can redraw this circuit like this. The two inputs are S bar and R bar, and the two outputs, output of first NAND gate is QT and output of second NAND gate is QT bar, which is complement of QT. Now we know that for NAND gate, two inputs are AB, then output is AB bar. We can make the truth table for this NAND gate. Inputs are AB, output is AB bar. For 0, 0, output is 1. For input 0, 1, output is again 1. For input 1, 0, output is 1. For input 1, 1, output is 0. Now we can see that for NAND gate, if any one of the inputs is low or 0, then output of NAND gate is 1. And if all the inputs of NAND gate is high, then output is low. So what if we short circuit the two inputs of NAND gate? Input is A, then output is A into A bar, which is A bar. So NAND gate becomes the NOT gate. Now we will make SR latch using this S bar R bar latch. This circuit is for S bar R bar latch. Now at the input we use this NOT gate using NAND gate. So we have at the input we have S and output of this NOT gate is S bar. Similarly for the lower part, input is R, output of this NOT gate is R bar. So this will make overall SR latch. Now let's make the state table for S bar R bar latch. Here we have first column present state, and the next two columns we have inputs S bar and R bar, and QT plus 1 is next state. Sometimes we denote it by QN and QN plus 1. Here we are using QT and QT plus 1. Present state is 0, inputs are 0, 0. We can see in the diagram also. Inputs are 0, 0, present state is 0, and complement of present state is 1. These two will go to the feedback. Now, for NAND gate, if any one of the input is 0, then output is high. So here we have both QT and QT bar, both are high, which is invalid state. Now try one more time. If these two ones go to the feedback, then again one of the input of first NAND gate and one of the input of this second NAND gate is 0. So output has to be 1. QT is also 1, QT is 1 and QT bar is also 1. So for input 0, 0, every time we get 1, 1 at the output, which is invalid state. Now let's see the next state. Present state is 0 and input S bar is 0, R bar is 1. S bar is 0, R bar is 1. Present state is 0 and the complement of present state is 1. These two, QT and QT bar, goes to the feedback. Now for first NAND gate, one input is 0, then output is high, and for second NAND gate, one input is 0, so output has to be 1. Now this is invalid state. We will try this for one more time. These two ones go to the feedback. Now let's see. Here For first NAND gate, one input is 0, so output is 1. And for the second NAND gate, both the inputs are 1, so output is 0, which is valid state. Present state QT is 1 and QT bar is 0, which is valid state. So for input 0, for present state 0, input 0, 1, next state is 1. Here present state is 0, inputs are 1, 0. So for the second NAND gate, one input is 0. In fact, both the inputs are 0, so output is 1. And for first NAND gate, both inputs are 1, so output is 0. So QT is 0 and QT bar is 1, complement, both the outputs are complement, so this state is also valid state. So if present state is 0, inputs are 1, 0, then next state is 0. Present state is 0, inputs are 1, 1. QT and QT bar go to the feedback. For second NAND gate, one input is 0, so output is 1. For first NAND gate, both the inputs are 1, so output is 0. QT is 0 and QT bar is 1, means they are complement. So this is valid state. For present state 0, inputs 1, 1, next state is 0. Now present state is 1, both inputs are 0. See, if both inputs are 0, then next state has to be 1, 1, which is invalid state. So these two 1 go to the feedback. Again we have one input of NAND gate as 0. So QT and QT bar both has to be 1, which is invalid state because it has to be complement. QT is 1, QT bar is 1, so it is invalid state. So if present state is 1, both the inputs are 0, then we get the invalid state. Here in S bar R bar latch, if both inputs are 0, then we get the invalid state. Next state, QT is 1, inputs are 0 and 1. For first NAND gate, input is 0. In fact, for first, both the inputs are 0 for first NAND gate, and so output is 1. And for second NAND gate, both inputs are 1, output is 0. So present state is, QT is 1 and QT bar is 0, which is valid state. So if present state is 1, inputs are 0 and 1, then next state is 1. Now for next state, present state is 1, inputs are 1, 0, 1 and 0, present state is 1, complement of present state is 0. These two go to the feedback. So for first NAND gate, one input is 0. For second NAND gate, one input is also 0. So both the outputs are 1. Now we will try one more time. For the second NAND gate, only one input is 0, so output is 1. For first NAND gate, both the inputs are 1, so output is 0. So present state is, QT is 0 and QT bar is 1, which is valid state. Here present state is 1 and inputs are also 1, 1. Here for first NAND gate, one input is 0, so output is 1. For second NAND gate, both the inputs are 1, so output is 0. So QT is 1, QT bar is 0, which is valid state. So if present state is 1, inputs are 1, 1, next state is 1. So this is the truth table or state table for S bar R bar latch. Now we will make the truth table or state table for SR latch using the truth table or state table of S bar R bar latch. QT is present state, inputs are S and R, and next state is QT plus 1. So if S and R are 0, 0, then S bar are 1, 1. So this is state 1, 1. Present state is 0, S bar are 1, 1. So next state has to be 0. For S0, R1, S bar is 1 and R bar is 0. S bar is 1, R bar is 0. So next state has to be 0. Present state is 0, S is 1, R is 0. So S bar is 1, S bar is 0, R bar is 1. So next state has to be 1. See, here I am writing unchanged. Present state is 0, next state is 0, so it is unchanged. For second state, present state is 0, next state is 0, so reset. Why reset? Because this reset is high, so next state has to be reset. For third state, present state is 0, next state is 1, so it is set. Why it is set? Because only set is high. Now for next state, present state is 0, S and R both are 1 1, so S bar R bar both are 0 0. So here, so next state has to be invalid state. Next state, present state is 1, inputs are 0 0. So yes, S and R both are 0, so S bar R bar both are 1. So next state has to be 1. Now this is unchanged. When both inputs are S and R, both inputs are 0 0, then there is no change in state. Present state is 1, next state is also 1. For next state, present state is 1, inputs are 0 and 1. So S bar R bar are 1 and 0. So next state has to be 0. Here present state is 1, next state is 0 because reset is high. So next state is reset. Now for 1 1 0, S bar R bar are 0 and 1. So next state has to be 1. Here present state is 1, next state is also 1 because only set is high. So this is also set. For next state, 1 1 1, S bar R bar both are 0. So next state has to be invalid state. So this is the truth table for or state table for SR latch. If S and R both are 0, no change in state. So state is unchanged. When only reset is high, next state is reset or 0. When only set is high, next state is set or 1. When both inputs are high, then it is invalid state. When both inputs are 0, present state is equal to next state, so no change, unchanged state. When only reset is high, next state is reset. When only set is high, next state is set. When both inputs are high, it is invalid state. Now let's make the excitation table for SR latch. For excitation table, not excitation table, we'll make the excitation equation or state equation for, in fact, state equation for SR latch. For that purpose, we will use 3 input K map. Inputs are present state, S and R. So this is the Carnot map for 3 variable, QT bar and QT, and S bar R bar, S bar R, SR and SR bar. Numberings are 0, 1, 2, 3, 4, 5, 6, 7. These are the values. Now we have 2 don't cares and 2 ones. So this will make 1 chord and these 2 ones will make pair. So the state equation QT plus 1 has to be S from this chord, and from this pair we have QT and R bar. So the state equation is QT plus 1, which is S plus QT R bar. So this is the state equation for SR latch. Now let's see the SR latch with active high enable signal. So to make the SR latch with active high enable, we will use SR latch, but these two inputs are not short circuited. Another input will be enable, which is E. So here the outputs are SE bar and RE bar. So if this enable signal is 1, this E is 1, so this SR latch will act normally. And if this enable signal is 0, then this SE bar becomes 1 and RE bar becomes 1. So this entire circuit will be disabled. Now we will make the state table for SR latch with active high enable when enable signal is 1. See, if enable signal is 1, then this SE bar is S bar and RE bar is R bar. So this entire circuit will act normally. So this will act as normal SR latch. Same state table. Now if it is 0, then see, if E signal is 0, then here we have 1, this is 1, and RE bar is also 1. So S bar is 1, R bar is also 1. All S bar, R bar are 1. So this will give no change. S E bar, R E bar. In fact, S bar, R bar are 1, 1. Then there is no change. Here also S bar, R bar is both are 1. Then there is no change. So present state is 0, next state is also 0. So in fact, this SR latch, if enable signal is 0, then totally disabled. There is no change in state. Present state is equal to the next state. In the same way, we can make SR latch with active low enable signal. So what should be the another input for these two NAND gates? We will use NOT gate, and input to NOT gate is E bar. Output of this NOT gate is E. So output of this NAND gate is SE bar, and output of this lower NAND gate is RE bar. So if E bar is 0, then E is 1. So this will act as normal SR latch. And if E bar is 1, then E acts at 0. If E is 0, then these two, S bar and R bar, both become 1. So this SR latch becomes disabled. So that's how we make SR latch using active low enable signal.